Okay guys, welcome back. We have two more videos, this one and the next one. So in this video, we will be doing create product and update product. And so we're going to need a product validator. So anytime a request comes in, we've got to validate each property that we care about so that we don't save bad data to the database. So we're going to have a layer of abstraction, and we're going to call that in both the create and update product endpoint. So let's start with create product. So for create product, this will be a post mapping, and we'll do /product. So this is interesting, right? Once we create the product, we want to return the product DTO associated with it. That way the UI can do stuff with it. So the product DTO contains the ID that is going to be generated once we create the new product. That way they can reference it and look at it. This is going to come in the request body as JSON. And we need to create a new class. So this will be our product request. So let's create that new class now. This will need a getter. And we'll have a toString constructor that'll help us debug later. Now we have a product request. Great. All right, let's create our command handler. And we're going to log, of course. We're going to need a product repository. And we'll need a category repository. Because what we need to do is ensure that the category they gave us is in the database. And if not, we're going to send them a message saying, hey, you can't do this. Okay, let's just start by logging. Now we're going to want a product validator. So in previous implementations, we wrote all of this code right here in the service class. The problem is we're going to want this exact same code to exist in our update product command handler. So the same rules are going to apply. So essentially what we're going to do is abstract this and put this in its own class. That way we can call it somewhere else. But once we're done, we're going to call product repository.save. We don't have the entity to save yet, but then we'll return response entity.ok with a new product DTO, and then we're going to pass in the product that we get. So we're not there yet either. Let's hook it up in our controller. Okay, let's create a new class. New Java class, product validator. So the product validator is not going to have any state. So it's just going to have a single method that's static. So public static is going to return a product. That's the entity linked to our repository. And I'll have one method execute. So essentially how this is going to work is we're going to have a bunch of if statements. And then each if statement will call a method that validates a property. Now, we're not going to do this now, but eventually we're also going to have one more if statement that does the profanity validator check. And this is where we have to make a call to an external API and do some API integration. So this is going to be a whole nother thing we got to do. But we'll get to that when we get to it. Okay. So when we pass in our method, it's going to be a product request. We'll call it request. One more thing we need is the list of categories. So list of categories, available categories. Okay, here we go. So if we'll say name is empty, where we pass in the request. And we'll define these methods later. Let's just kind of get the structure. So if we'll say price is negative, pass in the request. If category not available, pass in the request. And we also need to pass in the available categories. If region not available, remember region is just something we stored in memory in our Java project. So we don't need to do a repository call, but we do need to check the enum. Request.getRegion. And actually, here we should do getPrice. And here we should do getName. And then this will be our profanity validator. We'll come back to that. And we'll say to do. And then we're going to return a new product, and we're going to pass in the request. Now we do need to create a constructor here. So create constructor. And it's exactly what you would expect. So this dot name is equal to request dot get name. Okay, now we can use the IDE to generate these methods for us. So we can just say create method. And it automatically infers the type, so it realizes this was a string. It named it for us, and it even made it static. So super easy. So we're just going to say return string utils dot is empty. If you haven't used this before, all this does is it checks, is it null or is it empty? If it is, then it sends it back true. And then we're going to say name. Okay. Same thing. Price is negative. And I like to do it in order. So we're going to first check to see if it's null. So return price is not equal to null. So it'll check that first. But then it also checks price dot is less than 0. So if the price is negative, it'll be true. Next up, category not available. So what we need to do is say available categories dot contains. So if it contains, and we're going to create a new category with the, actually this should not be a product request, this should just be a category. So instead of request, we're going to say request.getCategory. There we go. So if it contains, then we want it to return false. So there we go. So what this is saying is, if it doesn't contain the category, return false. And then lastly, we need our region. So there are more elegant ways to do this. What I'm going to do is just loop over the region enums and then return false if we can't find it. So for region dot values, and you could certainly make a case for putting this somewhere else, but we're not going to do that for right now. And for region, I'm going to rename this to candidate region. Okay. If region dot name equals candidate region, then we're going to return false. And then else we're going to return true. We don't need an else case. So what this basically says is, if you can't find the region, then return true. So the point is, if any of these are wrong in whatever way, we're going to throw an exception. Okay? And remember, the way Java works is when you throw an exception, it never completes the method. So it'll never get down to this point. It'll just jump out of the method entirely. Okay, so for each one, we're just going to have a single one. So we're going to say throw new invalid product exception. Okay, and we're going to do that for each one of these. So let's create that exception. And we've already abstracted our exceptions pretty well, so this should be really easy, right? So extends custom base exception. There's our constructor. We are going to add our logger prime. And for our invalid product exception, we don't want to pass in a status. We know what the status is going to be. So we want a simple response, and we're going to pass in a product request. Our status is just going to be HTTP status bad request. And this is where we will call our logger dot error product not valid exception thrown. And then we can pass in the request. That way we know exactly what went wrong. We'll also get our simple response. And we'll get our get class dot get simple name. Okay. So when it gets thrown, we'll have a bunch of great information. Okay, so let's import. Okay, so we need to pass in a new simple response, and then error message dot product name cannot be empty dot get message, and then we're going to pass in the request. Now off screen, I wrote a bunch of error messages. So if you look here, I wrote, we already had product not found. I also wrote product name cannot be empty, product price, category, region, has profanity. We'll use that later. And if the profanity filter is down, there's another message. So go ahead, write your own messages, whatever makes sense to you. And I wrote them all in one place. That way they can all have the exact same grammar, format, etc. So I'm just going to be calling these right down the list. So I'm just going to copy this. And here's what I'm going to do. I'm going to copy it like this. And anytime I copy, I want to make sure it doesn't like it. You see how the compiler's mad? It means you can't accidentally forget to change something. So that's how I like to copy stuff. And a good check is if I come over here, you can see these have turned purple, which means they are referenced. So we haven't got to the profanity, so it's in gray. So this means I did the right thing. Okay, let's start working on our profanity validator. So we're going to be using an external service. I mentioned this earlier, but here it is. So we're going to use api-ninjas.com/API/profanity filter. So the Profanity Filter API detects and censors swear words, bad words, and profanity in any text. So you need to read the documentation and determine how to call this. Now I'll show you how to do it. But basically you make a GET request. So in your Java code, you need to make a GET request to this endpoint. And then whenever you make the request, so for example, they have some profanity here. If you send the request, it tells you what the original string was. It censors it. We don't need that. But then it says, does it have profanity? True. So this is the thing we're going to be checking. So let's just try something else. So there's our original, nothing needed to be censored, and has profanity is false. So we need to code up this response as well. One thing to note is that you do need an API key. So you can't just call this for free. Well, it is free, but you have to also include this API key. So if you don't have one, you need to come up here to My Account. And this is where you would show your API key. It's free. You don't need a credit card, but you do need to give an email address. And this is a great learning opportunity if you've never used an API key before. So go ahead and grab that. Okay, so we want to abstract the profanity validator. That way we can call it in our other class, right? So we're going to say profanity validator dot has profanity, and we're only gonna check two properties. We're gonna check the name and description. We could go ham with the manufacturer and other stuff, but for now we're just gonna do request.getName and request.getDescription. And we'll say throw new invalid product exception, new simple response error message dot product has profanity dot get message, and then we'll pass it the request. Okay, so let's create our profanity validator. Okay, as always, we're going to start with logging. Next, we're going to need our API key. So API key is equal to, and here's an important point. So for now, when you're working on this, you can literally just put it in a string right here and put your API key right here and it will work. However, you don't want to hard code API keys. So what I've done is I have an API key reader dot get API key. So if I come over here, essentially what's happening is down here in my properties file, I created a new file called API key.properties. And it looks the exact same as application.properties. I have a I have a field called API key. It has this name. It says equals, and then it has my API key. And so all this method does is it goes in to that properties file, and it gets the API key. So I just asked ChatGPT, please do this for me. So it looks in my properties file, it gets an input stream, it says this is the name of the file, and then we get the property specifically of our Profanity Filter API key, and then if we can't get it, then we return null. Okay, so that's essentially what happens. You can just copy paste this if you want. One more thing is if you're using Git, you want to add this to your Git ignore. So basically what this is saying is, hey, Git, do not upload this properties file. This is local only, and don't ask me to commit it to the repository. So you don't want to publicly share your API keys. That's a whole nother discussion for a whole nother day. If you don't want to do all that crap, you can just hard code it. So that's what I've done here, is just get my API key. If you don't want to worry about all that abstraction, just hard code a string right here. Okay. It's going to have one method, public static boolean has profanity. We passed in a string name and a string description. So remember your external API integration. So we actually need a header this time. So HTTP headers, because we're going to pass the API key through the header. You should have seen that in the documentation. So headers. Headers dot set. And we have to set the API key. So this is the key of API-key. And this comes straight from the documentation. It tells you what to do. And then the actual value is our API key. You could even pass it in as a string right here and it would work. And then we got to do one more thing. So HTTP entity is equal to new HTTP entity. And this is where we pass in our headers. So this is the thing we're actually gonna use. Okay, REST template equals new REST template. I think in the previous video we made this as a bean. That way there was only one instance of it. We could do that. I mean, I'm just trying to get to the end. So we could talk about different layers of abstraction, of course. But for now, let's just keep it simple and just do a new REST template right here. So this is where we're going to REST template dot, and we're going to specifically call exchange. So a little bit different than before. And then we need to pass in that the URL it tells us to do. So if we remember, it was https://API. And then it's a query string parameter, if you notice right here. Okay, so at the end, this is where we pass in, we're going to pass in name. So the thing we pass in, we're sending it to API Ninja to check to see if it has profanity. This is how we specify the HTTP method. So this is a get method, it says right in the documentation. We'll pass in the entity, this is where it has the headers and stuff. And then this is where our return comes into play. So if you remember, it told us what the response is going to look like. We need to encapsulate that and say profanity filter, I'm going to call it API response dot class, and we need to create this. So our product validator probably needs its own folder, don't you think? Now the only goal of this is just to ensure that it holds the data, so it doesn't have to do anything fancy. So we'll have a getter. I am going to do toString, so if we print it out later, we can know what it says. private string original, and this came straight from the documentation. It tells you exactly how the response is going to be, right? Private string censored, and then private boolean has underscore profanity. I think they're Python developers. That's why they use the underscore. That's my guess. All right, import. Great. And I have an error. What's the problem? Now this is going to return a response entity, of course, and it's going to return a type of Profanity Filter API response is equal to. And this is the response entity for the name. There's my problem. Okay, great. And then we're going to do the exact same thing, but for the description. So we're going to make two requests, one for the name, one for the description. That way we know exactly, which one faulted. We don't have to. We could send it all in one if we wanted to, but just a design decision. Description, response entity, and this time we send it the description. Okay, let's go ahead and log. So log.info. And this is where you might want to log the username, right? So you know who's putting curse words in. We're not going to do that here, but just something to think about. So the whole point of this is we want to determine, does it have profanity? So we're saying, does it have profanity? So if, basically we're returning, if the name response entity dot get body has profanity. This is our getter method automatically doing this. So I know this is ugly, but it's fine. Or description response entity dot get body dot has profanity. So if either one of these is true, we want to return, yes, true, this does have profanity. Now there's one more thing we need to consider. What if this API is down and doesn't work? We need to also be able to handle that specifically. So we're going to wrap this in a try catch. So try. And we're just gonna put all of this in here. And if this throws any exception, what we'll do is we'll throw a new Profanity Filter exception, and we need to create this error exception. So new Java class. And if you remember, I already did this one. So Profanity Filter down. And we also want to log it. So logger dot error Profanity Filter down exception thrown get class dot get simple name. Okay. Coming back to our product validator, I believe we're all done. So we're going to say if product validator, going to import, and then notice there's two exception paths, right? One is the API is up and it has profanity, then we throw an exception and we don't let them save to the database. Or we come in here, the external API service is down and we throw an exception here. Okay, coming back to our create product command handler, let's wrap this up. So the whole point was to validate our product, and now we are. So we're going to say product validator dot execute, and we're going to pass in the request. But this is interesting. My design decision, I have decided to pass in category repository dot find all, right? So our category repository, that's where we hold all of our categories. This should not be a long list. This should be less than 20, maybe max like 50, right? So a relatively small list. And I just passed this in to our validator method. and then I end up passing it once into our category not available. So we could have done a different thing here, right? In our product validator, perhaps we could have called the repository here and then done it. I decided not to do that now, and the reason for it is I wanted this method to just kind of live on its own. I didn't want it to be dependent on a repository being passed in, because I'm already doing that here. So that was my decision. I'm not saying it's the best or the rightest one, but that's what I decided. Okay. Now, if you notice one more thing, at the end, once we validated everything, we get to the end and we just return a new product. So we take that request, and with this constructor we made, we just create a new product. It doesn't have everything, right? It doesn't have an ID. So that's going to be generated by Spring when we save it to the database. And it does not have a created at or an updated at. That is handled with our database automatically. And one last thing I would like to say, when I look at this, I think this looks pretty elegant up here. It's very clear, it's all at the same level, everything has a good name. But when I get down here, I will say this is a bit cluttered. I have seen better abstractions where each validator is its own class. So for example, kind of like what we did here, where all of the logic for just validating the profanity lives by itself. I have seen that. I've seen other things like that. So just keep in mind, I don't think this is the absolute best way to do it, but for simplicity, this is what I did. And you can look up different design patterns of how to do more validation a little more elegantly than this, but okay, moving on. So in our command handler, now that we've gotten through here, let's save this product. So product, I'll call it validated product is equal to. And at this point, I can just call repository.save on the validated product, and it should work. And then this is why I always like the compiler to throw an error. That way I know to come back to it, okay? When we return it, now that we've saved this product, it's going to generate the ID and the timestamps. So let's go ahead and do a new product DTO where we pass in the validated product. And before we run it, just a couple of housekeeping things. I did add some extra annotations to some classes, so let me show you what these are. In category, I did add a toString method, so you can print it out easier. I do have a noargs constructor and an allargs constructor, a getter, an entity, and I also did an equals and hash code. This will help with unit testing later. And on the product repository, I did add a noargs constructor. Okay, let's fire it up and test it. Okay, so I created a new endpoint. So this is a post mapping on /product. I came over to the body and I have a bunch of stuff. So, okay, let's run through each one and see if it works. So let's say I don't pass in a name. Product name cannot be empty. Great. Let's, instead of saying empty string, let's try null. Product name cannot be empty. Great. We did have a price cannot be negative, so we'll say -1.0. Product price cannot be negative. Great. Let's say our category doesn't exist. Product category is not available. Awesome. And let's say our region is Mexico, which is not supported. Product region is not available. Great. We'll switch it back to US. And let's try adding a curse word. Product cannot be saved due to explicit keywords. Great. I'm going to delete it from the name. I'm going to add it to the description, and I'll try it in lowercase. product cannot be saved due to explicit keywords. Great. Now we didn't differentiate name versus description. We just said the same thing either time, which I think is totally fine. And everything looks good now. Let's try saving it. Okay, so we get a 200 status, okay. And it generated the ID and returned us the product DTO. Okay, let's open our database and see if it saved. And here we go. So super product description, we have our, so 36B, there it is, created at 2:20, matches up to our time. Toys Inc., super product, price is $1, region, and our updated at is the same as created at because it's the initial creation. So there you have it, create a new product with a bunch of wonderful validation. Okay, next up is our update product. Okay, now that we've done all the hard work, our put mapping is going to be really easy. So now we want to update a product, and all we have to do is call that validator class, and 90% of the work is already done. So here we go. So at put mapping, so here's an interesting design decision, right? Do we pass in the ID into the URL, or do we pass it into our product? Now up here, we did product request. And when you create a new product, you don't have an ID yet. So in our product request, there is no ID. So in order to keep this simple and reusable, what I've decided is to still use product request. That way we can still pass it into the validator. But what that means is we also need our ID to say which product are you updating. So this is kind of another design decision. We could have done this slightly differently. Okay, let's create our service class. And we actually need a new class. So update product command. And the command is just going to hold the product request plus the ID. That's it. Let's create our command. We'll need a getter, and an all args constructor. It's just going to hold private string ID and private product request product request. Actually, let's just call it request. Now we can import and implement the method. Let's link up our controller. And this is where we have our new command. So we just need it to hold the product request and the ID. So new update product command, where we pass in, and we need to grab this ID, which I did not do. So this is a path variable with a string of ID. So we need to pass in the ID and the request. Of course, we start off with our logger. And just like in our other class, we need a product repository and a category repository. So final I'm going to change this to command. So this is going to look really similar. So first we log .info. Okay. So the first thing we need to do is we need to find that product by ID. So we're kind of using multiple things here. So optional of type product, optional product is equal to product repository dot find by ID command dot get ID. So the first thing we got to do is if we don't find the product, we need to throw an exception, right? So if optional product dot is empty, we need to throw new product not found exception. Boom, done. The more stuff you write, the easier it gets, right? Then we need to run it through the exact same product validator. So product validated product is equal to product validator dot execute. And we're going to pass in the command dot get request, and then we need to pass in the category repository dot find all so that we can find the categories, right? So let's just track what happened, right? A request came in. First thing we did, if we couldn't find the product, throw an exception, get out of here. The next thing we do is we validate the request that came in, okay? Now at this point, we are happy with our new product request that came in, and we know that the ID is valid. So what we have to do is we have to say the validated product dot set ID. So we take the ID that was passed in and we set the product and we set the request to the ID. Because remember, the request itself doesn't have an ID. And the way it updates is using the ID. So we're going to say optional product dot get ID. One more thing is that it does not automatically save the set created at. I had to learn this through testing. I went and looked at it and realized it didn't. So validate product, sorry, this should be validated product dot set created at. So optional product dot get created at. So what we do is we go to the database, we get that created at, and we make sure that that is saved when we do our repository.save. So now we do our product repository.save. Remember, save can either create a new or it can update an existing, and it does it by the ID. So then we pass in our validated product. Now we're going to return a response entity .ok with a new product DTO where we pass in our validated product with all of the great information. And that should be everything in terms of development work. Of course, we need to do unit testing, but let's launch it up and test it manually. So I've already created the endpoint. So this is a put. And what I did is I went to the database and I found our ID 36B. I copied this. I put it right here. And then instead of a super product, super great product, we're going to call it a lame product. And we're going to say, don't buy this, man, it's lame. And then we change the price, we multiply it by 10, and we're going to keep the same category, electronics, same region. So let's see if it goes through. Okay, it looks like it worked. We got a 200 status. We got an update. Let's do a select star. Okay, it looks like it works. So same ID, and then everything got updated. Okay, great. Now let's see if everything else applies. So let's try our profanity filter. Good. And you can do the rest of the testing yourself. I already tested it, and I am confident that everything is working, but I leave that as an exercise for the user. You, of course, need to make sure that everything is working appropriately. You cannot assume that. Okay, moving on to unit tests. Okay, it is me from the future. I just wrote all of the unit tests, as you can see down here, but to get there, I had to rewrite some of the code because I just realized it wasn't very testable, and I made a few little small design changes to the code. So let me show you what I did. First thing I did is I realized, we really don't need to make this call twice. And the reason is we're only returning the same message regardless of if it's in the name or the description. So instead of making 2 calls, let's just make 1. So I just deleted the first one. I rename this to response entity. We no longer need this guy. We no longer need name. And instead of checking both, we can just check one. This should speed up our system as well. Now remember to also pass in your name. So plus name plus description. Okay, great. The next thing is I did just create a new REST template right here, but what I realized is to unit test this, we need to be able to mock this REST template. So let's go ahead and abstract this, create a bean, that way we can reference it anywhere and also mock it correctly. Alrighty, so I'm going to create a new file in our configuration. I'm just going to call it app configuration. So we annotate it with @configuration. We have a bean, and the reason it's a bean is because we have to instantiate it manually. So public REST template, and we're just going to return a new REST template. Okay. So coming back to our validator, we're going to go ahead and remove this. And instead, we're going to inject it using dependency injection. So up here, we're going to say public final REST template, and then I'm just going to generate a constructor. There we are. And you can't access this non-statically, so I'm just going to remove our static keyword. There we go. And auto format. There we are. Okay, now we have to just update a couple other classes. Before we do that, we're going to annotate this with @component, which allows it to reach up into the Spring container and get some stuff. Okay. So moving back over to our product validator, where are you? Oh, and this is in the wrong folder. Let me move this here. Go. Okay, so in our product validator, what we are doing is, where is it? We used to call it from a static context. So now we're going to do the same thing. We're going to use dependency injection and inject it in. So we're going to say private final profanity validator, and then we'll do the same thing. Generate constructor, and we're going to annotate this with @component as well. And then you can't do this non-statically, but let's see. Yep, you can't access it in that way, so we're going to remove static, and then we should have access to it. Profanity validator has profanity. There we are. Perfect. Okay, moving up our stack, let's go to our create product command handler and our update product command handler. So here again, we have it in a static context. So we're going to do dependency injection. So we're just going to say private final product validator, and we're going to add it. Probably a good time to hit the enter a couple of times. Okay, great. And then down here, we're just going to do it this way. That way it's nice and purple. Do the same thing on create product command handler. So Okay, and then during unit testing, I also needed a couple more things. So in our product request, and I could probably organize this a little bit better, but I did end up needing a setter, and I did end up needing an all-args constructor. So just as I went through and I tried to create these, I realized I don't have a constructor, so I just came back and added it later. These are the things that you just add as you go, as you need them. And then lastly, on the Profanity Filter API response, I did end up needing a setter as well. And I did generate a constructor with just the has profanity. And the reason it's just this value is because this is the only value we look at. We don't look at the original, we don't look at censored. All we ever touch is has profanity. And technically we could, just have this property and do JSON ignores the other two. But I decided not to do that for completeness sake. But this is the only one we care about. Okay. With my unit tests already built, you can see in my changelog, let's just do a build and make sure everything compiles. Okay, perfect. So let's look at our unit tests. And I'm going to compare them side by side with our actual class. So let's start with, the easier one. We're going to look at our profanity validator. So if we look at this, what do we want to test? Well, we want to test 3 cases, right? At least that's what I see. So one of them is, does it have profanity? Meaning, if we have a certain response, does our code return true? If it has a different response, does our code return false? And then lastly, if this service is down and we get some sort of exception, do we throw the proper profanity filter exception? Okay, so I'm not going to type out my unit test again. I'm just going to show you. So first thing, annotate it with @springboot_test, right? We're going to mock the REST template, and then we're going to mock the profanity validator. And then we have a before each. So this .profanity validator is equal to new profanity validator, and we pass in the REST template. So this is what we did earlier for our dependency injection, right? Okay, and then we have the 3 tests: returns true, returns false, and then throws exception. So let's just look at returns true. So what we're doing is we're mocking the response. So if we come over here, what we're doing is saying, okay, given we do this method and it returns this, does our code do the right thing? So profanity filter API response is equal to new profanity filter API response, and we pass in true, has profanity, right? This is the constructor we just created. And then what we do is we say, okay, when the REST template, and we do that exchange, so we're mocking this, where is it? We're mocking this exchange method. So during this test, if any string is passed to it with an HTTP method of get, and you have to do this little equals thing, and we do any HTTP entity.class, and it equals a profanity filter API response.class, then we're going to return a new response entity with our response. So when we hit this, it returns this response, right? So all we have to do then is assert true. We actually run it through. Profanity validator has profanity. We just fill in some garbage, right? Because we said any string here is fine. And we're asserting that that is true. This next test is the exact same, literally word for word, except instead of true here, it's going to return with false. And if it returns false, we want to ensure that our method returns false. So we're asserting that our has profanity, okay, this whole method, return false. Okay. Last one is test if it throws the correct exception. So this time we don't need a response because it's not going to respond with anything. It's going to throw an exception. So this is the same as up here. The only difference is it's going to throw a generic runtime exception. Okay. So then we run it through. We say And then we're going to assert throws, and then we just run it through the method. Profanity validator has profanity, throw in some garbage, and then we want to make sure that it threw the correct exception, right? We want to make sure our code with our custom message got thrown. So let's run this. I'm going to make sure this works, even with my change. Great, okay. Simple, simple. Okay, so that's the only 3 unit tests that I wrote for the profanity validator. Okay, now let's look at our product validator. So if we look at our product validator, I wrote a unit test for each one of these throws conditions, right? We want to test each one. And then this one has to get a little more complicated because we also have to mock this response. So if we look at our name is empty, right? We're checking is empty, which checks null or empty. So our first test. So first up, again, Spring Boot test with our final exam application test.class. We are mocking our product validator. We also have to mock our profanity validator because we do use it in one unit test, right? And then we instantiate it. So this product validator is equal to new product validator, okay? And we pass in the thing we need. So the first thing we test is this first line. If we pass in a product, then does it throw an invalid product exception, but we also want to check that the response is correct, right? So the first thing I did is down here at the bottom, I created a method that just returns a new product. And this returns a valid product, right? So it does have a name, it does have a description, okay? And all I do in each test is I come up here and I say, I get the valid product, and then I explicitly set the thing I care about to null. Then I run it through the method. So product validator.execute. Our product request null is passed in. And then I also have a method for get categories. So this time I have 2 categories, electronics and food, just to make it work, right? And I'm asserting that this throws an invalid product exception, okay? And then I'm also asserting that this exception, the message, is equal to product name cannot be empty.getMessage, right? So all of these are invalid product exceptions. So I want to make sure that the correct message is being thrown. Okay. I also added one more test. Could I have made this another separate unit test? I could have. I did not. And I'm doing the exact same thing as above, but instead of null, I'm passing in empty string. Right? And it returns the same message. So next up, it's the exact same format right down the line, right? I get a valid product. I explicitly set the price to something I don't want. So price is negative. So if we come back here, we say price cannot be negative. We then assert that once we product validator.execute and we pass in the request and pass in the categories, then it throws the invalid product exception. And then we assert one more thing, that the product price cannot be negative, right? So you should get the pattern now. Here's our category not available. I also wrote another unit test for is the categories empty. So for example, if we pass in collections.emptyList instead of a list of categories, does it throw the same thing? And it does. Maybe this tells us when you want more code that gives a different error message, but the business did not ask for that, so we're not doing it unless they ask. Same thing for region not available. We set our region to something we know is not available. We only had US and Canada. Okay, here's the interesting one, right? So for this one, profanity, we also have to mock this response, right? So what we have to do is say, okay, if during our test this method is called, we want to return true. It has profanity. What we're testing is, okay, if this is true, do we throw the correct exception? We test this method in our other class, right? So that's why they're called unit tests. We're testing a unit of code, not all of it together. So if this returns true, we want to make sure that this exception is thrown, okay? So we get our valid product, okay. But what we're saying is when product validator .has profanity is called, even if we pass in anything and anything, then it's still going to return true for this unit test. Then we assert that the invalid product exception is thrown when we do product validator.execute, and then we assert the message product has profanity. So let's just run all of our unit tests and make sure they all pass. Remember, you can also go to the terminal and type in mvn for Maven and test, and that will do the same thing. Okay, 20 passing unit tests. This is great. And the process I went through when I realized, oh crap, I can't really test this that well, that's a normal process. You'll have to go back and refactor code and move things around and just make them more testable. And testable is good. It means you've got explicit units, and it means your code is more up to snuff in terms of design patterns. Now, one more thing we did not unit test, but you could, is if you come to the update product command handler, our update product command handler did have some extra logic, right? It did have throws product not found exception, so you could definitely add a unit test for that. We've already done that elsewhere, so you should be able to handle that by now. We also set the ID and we set the created at. So to make sure that these things get set correctly, those could be unit tests. You should be able to do that, no problem. And yeah, so I see maybe 3 more unit tests we could write specifically for the update product command handler. But the cool thing is since we abstracted the validate product, those unit tests work for both the create and the update. So we don't need to duplicate all those. And this is the great advantage of separating out all of your code and doing a more clean design pattern, fewer unit tests. So anyway, that's it for all of our features. We are now feature complete. The last video will be dedicated entirely to security. So we're going to lock down these endpoints, and anything where a user is mutating the database, they will not have access unless they are a valid user. And we're going to add JSON web tokens and all of that fun stuff. Okay, I'll see you then.